This is our Earth. Right now, you are sitting on a rock hurtling through space at 67,000 miles per hour, protected by an invisible magnetic shield so powerful it deflects radiation bullets fired from the sun before you ever feel them. You have never thought about that shield once in your life. And 140 million miles away, there is another rock. Same age, same birthday, same ingredients. But that rock lost its shield 4 billion years ago. And now, standing on its surface would give you 3 chest X-rays worth of radiation. Every single day. That rock is Mars, and we are desperately trying to move there. But why? And can we actually survive? Here's the uncomfortable truth. We're not going to Mars because it's exciting. We're going because we're scared. 400,000 years ago, humans learned one rule that kept our species alive through every catastrophe nature threw at us. Never exist in only one place. One asteroid, one pandemic, one supervolcano. If everything is in one place, everything is gone. Mars isn't an adventure. Mars is a life insurance policy for every human being who will ever live. And of every option in our solar system, Mercury melts you, Venus crushes you, the gas giants have no ground to stand on. Mars, broken and frozen as it is genuinely the best option we have. But getting there, that's where it gets truly terrifying. People think Mars is like the moon, just further. It is not even close. Apollo 17 reached the moon in 3 days. 6 astronauts going to Mars would need 174 days just to arrive, then wait 539 days on the surface, then 201 days back home, 911 days away from Earth, completely alone. And the fuel needed for that round trip? Between 850 and 1,250 tons. The entire International Space Station weighs 420 tons. You'd need 3 of them, just in fuel. Oh, and if something breaks on Mars, the nearest help is 140 million miles away. A radio message takes 24 minutes round trip at the speed of light. There is no calling for help. There is no rescue mission. And that's still not the most dangerous part. It started with a race. 1964, Cold War, USA versus Soviet Union. 2 superpowers, not just competing for land or money, but competing for the entire universe. The Soviets tried first. They launched Mars 1 in 1962. It lost contact before reaching Mars. Then tried again. Failed again. And again. The Soviets attempted Mars 18 times. 18. And failed almost every single one. Then in 1964, NASA's Mariner 4 finally made it. The first spacecraft to successfully fly past Mars and send back real images. What those images showed crushed humanity's hopes completely. No canals, no cities, no life. Just a barren, cratered, dead world, with an atmosphere so thin it barely existed. But we didn't stop. In 1976, NASA's Viking landers actually touched down on the Martian surface. For the first time in history, humans had eyes on another planet's ground. They found rocky terrain, ancient riverbeds, evidence that Mars once had floods powerful enough to carve valleys the size of continents. Mars wasn't always dead. Something catastrophic happened to it. Then in 2004, NASA's twin rovers, Spirit and Opportunity, landed. Opportunity was supposed to operate for 90 days. It survived for 14 years, alone, on a dead planet, sending data back to Earth until a global dust storm finally silenced it in 2018. Scientists at NASA reportedly said goodbye to it like losing a family member. And then came the mission that changed everything. In 2021, NASA's Perseverance rover landed in Jezero Crater, an ancient lake bed. Alongside it, a tiny helicopter called Ingenuity. Nobody was sure Ingenuity would even survive the first Martian night. It not only survived, it flew. For the first time in history, powered flight on another planet. And Perseverance? It has already done something no machine has ever done before. It produced actual breathable oxygen directly from the Martian atmosphere. We made air on Mars, real air. But here's what all of this is building toward, and why the next decade changes everything. Here's a sentence that should stop you cold. Every Mars colonization proposal begins with optimism and ends with radiation math. On Earth, our magnetic field wraps around the entire planet like an invisible fortress. It deflects cosmic radiation that travels at nearly the speed of light, particles so energetic they can snap DNA strands like dry twigs. You have never felt this protection, but it has saved your life every single day since the moment you were born. Mars has none of it. The result? Mars bombards you with 40 to 50 times more radiation than Earth. And the terrifying part? You feel nothing. No pain, no warning, no alarm. It silently enters your cells, breaks your DNA, collapses your immune system, builds toward cancer so quietly that by the time you notice, it's already too late. Engineers say, just live underground. But someone still has to go outside to fix the solar panels, tend the crops, repair the seals. And those crops? Martian soil is chemically toxic, packed with perchlorates that destroy thyroid function on contact. Every hour outside, another radiation dose, in tissue that is already compromised. This isn't a movie. These are real numbers from real NASA probes sitting on Mars right now. And yet, here's what genuinely gives me chills. If we somehow survive long enough, Mars will start changing us. Future generations on Mars would evolve thicker bones, smaller hearts, larger skulls, and scientists predict an entirely new skin pigment, orange, as a biological shield against the radiation. Over thousands of years, they wouldn't look like us anymore. We wouldn't call them humans, we'd call them Martians. So, is Mars a giant mistake, or humanity's greatest act of survival? 400,000 years of history says, we already know what we'll choose. We always go. Do you think we should? Drop your answer below. I read every single one.